Hello and welcome to another video. In this video, we're going to be going over Reorganize string. So in this problem, you're given a string S and you want to rearrange the characters such that any two adjacent characters are not the same, and you want to return any possible rearrangement of S. So it's pretty intuitive what to do here, but yeah, essentially, so if you have AAB, you would want to return something like this. Then for AAAB, you can't really, there's too many A's, so you can't really do anything. But this is probably one of the most intuitive algorithms, I think, personally, on what to do. But essentially, what you want to do is, let's say we have some word, right? Whatever it is, like A, B, B, or whatever. Essentially, all we want to really do is use the most frequent character as often as possible in the word. So for example, in this word, let's just say we have this word. Let's just say we have like this, right? So what we want to do is, first of all, we want to have a hash map for every character. So it'd be like 4, B3, C1. And I'm going to show you like the intuitive approach of what to do, and then we have to figure out how to actually make that happen. Essentially, whenever we can use the biggest character, we want to use it. So like here, we would use an A, and then it would go down to, let's say we had 5 A's. So we'd use an A, it would go down to 4. And now we would say, okay, what's the most frequent character? Okay, it's A again. But we already have an A. So we can't use it twice in a row, so then we want to get the second most frequent character, which would be the B. So then we would put in a B. Then this would go down to 2. Then you try again. Okay, let's try to use our A, because that's our most frequent. We can use it. Okay, perfect. All right, now let's decrement that. Okay, now let's try to use the A again. Okay, well, we can't. So you see how like the pattern is, we can't use the A, so we'll use the B, and this will go down. Then we try to use the A again. Now this will go down to 2. Then we try to use the A again, but we can't. So then we'd use a B or a C. Let's just say a B. And this goes down to 0. Then we try to use the A again. Goes down to 1. And then now we can use either one of these. So we can't use the A, so we would use the C. This would go down to 0, and then we'd use the A again. Essentially, you try to use the most frequent character as often as you can. And let's look at our cases that can happen. So let's write this down. So use most frequent character as often as we can, and then if we can't use it, then let's use the second most frequent character, right? Because naturally, if we had, let's say if we had an A with a count of 10 and we had B with a count of 9, B with a count of 9, we'd want to use the B, right? We'd want to use the B because we want to minimize our counts as much as we can, so then we can fit all of our things. But how do we ever run into a problem? So the problem, there's a couple problems we can run into. So A, if we don't have a biggest character, well, what would happen then, right? Like if we don't have a biggest character, then we need to check. This essentially means we don't have any characters left. So that's one case, right? If we don't have any characters left, or not really any characters left, it would be more like, no, actually, yeah, it would be if we don't have any characters left, essentially. That would be one of our cases, right? So if we don't have any characters left, then we're done, right? Like that'd be fine. If we don't have any characters left, then we are done. But what are some of the issues we can run into? So the issue we can run into, there's only one really, and that's if we do have the biggest character, if we have only one character left, but we can't use it, right? That's our like base case where we can't do anything, right? So we have two cases. Either we just use every character, or like in this example here, you know, we're gonna have an A with a few use cases left. Like we can write like A, B, A, but then we have an A left over with a count 1 and we can't use it. So that's our last case, is if we have a character left but we can't use it, then, so for this we return true, for this we return false. And now it's pretty straightforward. Like all you do is you try to use your biggest character whenever possible, then you try to use your second biggest character whenever possible. And if you ever run into a case where you only have your biggest character and you can't use it and you have nothing else, then you would return false. So now this problem boils down to how do I get the biggest character and the second biggest, right, in terms of frequency. And there's two ways you could do this. The first way I thought of personally doing was you can make a helper function. It'll just go through your dictionary, and it will just get the count of the biggest letter and the count of the second biggest letter. Pretty easy to do that. You just have two variables for that, right? And you loop through all your keys. That would be O of 26, and you can do that every single time you want to get your second biggest letter. That's one way you could do it, and that would be totally fine. And the second way to do that would be a heap. And a heap's a little bit more intuitive. So with a heap, we're just going to store the counts of every character. So like, for example, with A's and B's, let's say we're going to have a heap, and we're just going to have the letter and the count. We're going to have the count first, so let's call that C, and then we'll have the letter second, right? So it'll look like, you know, for a word like A, B, 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 we would have like 4, A, 3, B, and then we're going to store these as negative values because we're going to have a min heap, so we want the biggest count first. And then we can simply just pop values, right? So we can just pop values, and then we could just check the counts that way. We could pop values, we could push them back in, and popping the value would give us the biggest count right away, and if we pop the biggest count and we pop again, we get the second biggest count and so on. So that's a little bit more intuitive than a helper function that actually loops through your keys and values, but you could do that. Either way is fine, and the nice thing about all these things is because these are O of 26, you can technically say they're O of 1 because it's only 26 letters max. So this Q will only be 26 letters, this counter will only be 26 letters, so you can say you're using constant space pretty much. And the time complexity for popping, like, it's going to be kind of similar because if you go through a list, that's O of n, but it's only 26 letters, that's constant time. And if you do heap pops and heap pushes, that is log of 26, which is also constant time. So either one works. The heap's a little bit faster because you're going to have logarithmic insertions and deletions. But like I said, it's only 26 max, so either way you can argue they're constant time. It'll just be a little bit faster on LeetCode. But essentially that's all we need to do is we just need to have a heap with all of our counts. And then for all our counts, we just keep pushing and popping back and forth until we get rid of every single letter or until we have one letter left that we can't add. So those are our two edge cases. One letter that we can't add because it was the last letter, or we got rid of every single letter. Okay, so now we can code it up. We have enough. So first we're going to make this heap. So we're going to call this letters, and we are going to use a list comprehension here. So we're going to make a negative value because we want it to be negative because we want the biggest value. It's a min heap. Negative value key for key value in, and we're going to have counter here dot items. And so if you didn't know, items in a dictionary is going to be a list of key value pairs. You could just make a counter and you could just loop through this. So you could totally make a counter here, counter, and then you can just say like for key, and then you could say like counts key or something, you know, that would be totally fine. But we're going to do it this way. Okay. So now what we need to do is we need to heapify it. And yeah, the originally way I did this with a helper function, but it's a little bit less intuitive, so I'm just going to show the heap way. But it's basically the same thing. You can practice the other way with a helper function that just loops through all your values. Then you just have your biggest value and your second biggest value equal to null. And then if you can ever fill up the biggest value, fill that up first, and then you fill up the second value second. It's roughly the same logic. Okay. So we're going to loop while this letters exists. While this heap of letters exists, let's just keep doing stuff. So we're going to get the biggest letter and the second biggest letter. So we're going to say biggest equals heap pop from letters. And now what we need to check is, can we use this letter? So if there is a result array, and so remember that biggest is going to look like, let's just write it over here. It's going to look like a number value and then the letter, right? So if the last letter in our result equals the letter for biggest, right? That means we can't use it. So we can't use this letter. So now what we can do is we can actually check if the heap is empty. And if the heap is empty, there are no other letters, we can just return straight away. Otherwise, we can pop another letter, and that will be our second biggest letter. And that's our algorithm, right? We ideally want to use the biggest if we can, but if not, let's use the second biggest. So we're going to do second, same kind of thing. Heap pop from letters. And then we are going to, so now we know we can use the second biggest letter, right? Because you can have alternating characters. So if you can't use the biggest character, you're guaranteed to be able to use the second biggest character for sure. We don't have to check for that. So we can append that character. And once again, second is also going to look like this. So let's write that over here. Okay. And now we need to, so remember, this is a value in a letter, and we're going to be storing them negatively. So this will be like -3 or whatever. So to actually decrease the count, we need to add here, right? So if this had a count of like -3, we'd want to add one to make it -2. So we would say second 0 plus equals 1. And now we have to actually check, like let's say that count was, or let's say our count was 1. It would be stored as -1. We would add 1. And now our count would be 0, and then we wouldn't want to put it back into the heap. So we have to make sure if there's still a count remaining. So if second 0 does remain, then we want to push it back in. Letters second. And we always want to push in the biggest letter regardless, because this is the situation where we didn't use the letter. So we're always going to push in biggest. Okay, there we go. And now we have our else case where we can use the biggest letter. So if we can use the biggest letter, it's going to be kind of similar. So it's going to be biggest 0 plus equals 1. We're going to add 1 to it, and we're going to use it. So res.append biggest 1. And then same check as here. So if biggest 0, heap push letters biggest. And now finally, so I think I tried to check if the length of our result is long enough, but I don't think we need to. I think we can just join it. It should always be long enough here, assuming we used every letter. So I think we can just do a join here. So we can just do this, join on result. Let's see if we do need to check. We might have to, but I don't think so. Yeah. So, and this is like totally random for as far as efficiency, because everyone has kind of similar solutions. So it's as efficient as the other ones, as you can see. Okay, so let's go through the time and space here. And yeah, like I said, technically you can argue that these are all O of 1 space, and that's what we are going to do. So essentially we build up this counter. And so when we build up this counter, this is O of n space, where n is the length of the string. Then we will be heap popping and heap pushing. And how many times will we do that? It's going to be O of n as well. So this will be like n log. And how many letters are there? There's only 26 letters, right? So that's why this is going to be O of 1, because you're essentially doing, there's only 26 letters here. So this is going to be O of n time with the heap pops and heap push. And then you're going to be adding to the result, which will also be O of n. And then for the space, so we have two things. We have a counter, which is a dictionary with only 26 letters. And then we have a heap, which can only hold 26 items as well. So that's going to be O of 1 as well. But yeah, that's going to be all for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.